Alright, so welcome to the second part of our Across the Thingiverse webinar series. What we're doing is we are slicing parts from a 3D file repository. We're slicing them at random, right? So this is the first time we're seeing these parts, just like it's the first time you're seeing them. And we are going to be slicing them for printing on a SLA or resin printer. In this case, it'll be Formlabs, and our slicer will be Formlabs slicer called PreForm. Now, this is the second video in the series, our last video being on slicing for FDM printing. And in that case, we were using Eiger, which is Markforged slicing platform. And as before, we're going to be following the same rules. So we're going to be using Thingiverse, slicing parts using a random number generator. We are only going to be slicing parts that are free to download. We're not paying for anything. Now, the third rule really applied for FDM printing, because with FDM you have to really plane cut. You got to really mess around with stuff in CAD, especially if you're dealing with a part with a lot of complicated geometries. And so I put this rule in here. Let's look at parts that are fairly basic. Let's not do anything too complex, because it can bog down the slicer in that. I'm going to change this rule a little bit for this one because we're dealing with a different technology, and as such, we can actually afford parts that have greater complexity. That's really one of kind of SLA's party pieces. Anyone who has ever seen a part printed on a resin printer, the parts look really detailed. They can capture details well, can capture accuracy very well. So I'm changing this rule to accepting parts with a complexity that might be challenging for FDM, and of course we'll kind of play it by ear depending on the part that we get. If it's too crazy or whatever, maybe we'll reconsider. But that's kind of what we're going to start as kind of a starting point here. And then lastly, we'll just stick with kind of general parts, nothing too controversial. So with that in mind, let's go into Thingiverse. Okay, now as before, I'll just explain this briefly. If I were to click on a part like this spice rack, what you'll notice is up here in the URL, we have thing, : and then some kind of number. Every time a part is uploaded to Thingiverse, there is a number associated with that part. So that's kind of where this random number generator thing I've been talking about comes into play. So what I'll do is I'll open our random number generator, just using this one from Google. And I've set the minimum, which is set as 1 as default. But the maximum I've set to 10 million. That seems to be, roughly the highest number that's there in Thingiverse. If I set it too high, then I'll just have tons and tons and tons of 404s. So 10 million seems to be a good spot. And I'm going to generate this. And I've got this number here, somewhere about 7.5 million. And I'm going to select this and paste this in here. And you can see I have a 404, so there's no actual part associated with this number. So what I'm going to do is I'm going to run through a bunch of these until I eventually get a part. It might take me several tries, so just hang tight.
3 hours later.
Awesome. Finally a part, and this one looks pretty interesting. It says slashback differential half cover. Only half of it, the other one is work in progress. Yeah, nice word there. I'm going to blur that one out. Alright, cool. So we'll grab this part here. And I'm going to go ahead and download this. And while that's downloading, I am going to open PreForm. So PreForm is a desktop application, free to download, and it's the slicer that Formlabs uses to convert your 3D model into a kind of G-code compatible file that the printer can then read. And immediately what you see right here in the center of the screen is the representation of our build volume. For us, we have our Form 3L build volume here, which is our larger format resin printer. And here in this selection window, we have the ability to, if I click on this, we have the ability to select the printer, select whatever printer is currently connected to the internet, which is our Form 3L in our office. Then we choose our material. You can see Formlabs has a pretty wide selection of different resins, from standard modeling resins like the gray that I have selected currently, up to some pretty high performance engineering resins. And then once we have that selected, we will choose our layer thickness or layer height. And so here I have 0.1 millimeters selected, but you can go down to 0.025 millimeters for this material, which is, for really fine details, really high precision, accuracy, all that good stuff. So just going back to our window here, what I will do to load in the part we just downloaded, just go up here, File, select Open, and we'll just select our part. And a window appears here that says, hey, your STL file's got some bugs in it, and fortunately PreForm has a way to repair that. I'll just click Repair, and there's our part right there loaded in. Now, my plan for this part is to walk through this process from slicing to printing a little bit slower, just so you guys kind of get the feel for how it works, and then the next parts will go more rapid fire. Now, whenever I first load in a part, first thing I like to check is just reviewing the cross-sectional area within each layer as we move from the bottom of the part up to the top. And this little slider that I'm using is a feature in virtually every slicer. Okay, by going up and looking at each layer, you can kind of gauge, okay, here are some maybe challenging geometries. These are some areas I need to focus on. But it's also useful, particularly in SLA printing, because the cross-sectional profile is kind of going to gauge the peel forces that we're going to be dealing with. And the peel forces are something that's very unique to this inverted or upside down kind of style of resin printing. Because as we print, we are dealing with two forces that are operating in opposite directions. So in one direction, we have our bed adhesion force, which obviously is what glues that part to the print bed. But in the opposite direction, we have our peel forces. And so what's happening as we print each layer is the laser is passing up through the bottom of this clear resin tank, and it's curing that layer to the bottom of the tank. And so in order for us to print the next layer, we have to peel that part up off the bottom of the tank, and then the build platform has to descend back into the resin tank to start printing and curing that next layer. And so that's where those peel forces come in, and we need to keep those peel forces as small as possible, because otherwise it could cause that part to break off the build platform and we have a print failure. So that's what I'm doing. I'm just making sure that we don't have any sudden increases in our cross-sectional area, because that's going to produce a pretty sizable peel force and it could cause a problem. So anyway, that's what I'm doing there. This one has a really thin, kind of maintains a thin cross-sectional area here, so that looks good. But what you'll notice is over here on the right, we have some printer health checks. And for one, we have a warning that says, hey, your models need more support. And that's what you can see all these kind of red highlighted faces in here are referencing. But we also have another warning that says, hey, your models are printed directly on the build platform. This, you can get away with this for sure, but it's one, going to cause difficulty in removing that part. And two, whenever you build a part directly on the build platform, you have to contend with kind of an elephant's foot right on the first several layers. So the laser is kind of spending a little bit more time on the first several layers, trying to overexpose the resin, over-curing it so that it forms a really good bond to that build platform. So that elephant's foot's going to cause some dimensional issues there. So it's typically not advisable to print directly on the build platform. The next step we want to do is we want to support this part. And before we do that, we want to just orient it. Typically what I like to do is orient it 30 degrees about the X and Y axis. So I have the option to just drag these sliders here, or I can select the orientation button here on the left. So for the X axis, we'll set it 30. And for the Y axis, we'll do the same. Now this part maintains a really good kind of thin cross-sectional profile, so I'm not too worried about it from there. And that's not the reason really why I'm orienting it like this, but mostly because it's what kind of guarantees a successful print here, especially because down here at the bottom you can see that we're starting from a very small cross-sectional area and then gradually growing. We're not putting too much stress on the printer. So from here, what I like to do is, in the supports, I just rely on PreForm's auto-generated supports. So once those generate, you can see that with resin printing, you deal with these kind of localized tree supports, and you have all these individual touch points. And so in this box, I have the option to adjust the tree density, and I also have the option to adjust the touch point size. But for the most part, I leave these pretty much default. And PreForm does a really good job identifying where the minima are, where kind of like islands, like you can see one right here, kind of a region where a part is generated in thin air. It's really good identifying those regions and supporting them accordingly. And you can also see over here on this hole feature, it does a really good job supporting this. You can see the first couple supports are touching off there, and that's because we're producing a very gradual angle as we move up the part. And those angles need to be supported, otherwise we might come out with a kind of oblong hole, which would not be advisable. And then we have some internal supports like this one here. If you don't want that, you can uncheck that box. Another reason why I opt for the 30-degree rotation is because resin printers can actually handle unsupported angles as low as 10 degrees. So with 30 degrees, it's a nice trade-off. And so you can see here, like on some of these faces, right, I have some supports, but as we rotate the model, I have, very few supports on that face, very few supports on that face, and just minimal supports on that face. So it's a really good trade-off, good balance. But I'm good with this part at this point. What I'll do is I'll just select Upload Print down here at the lower right. And we actually have a printer connected to the internet, so I could send the print job directly. Or I could plug my laptop directly into the printer if I don't have it on a connection, and I could print it that way. Alright, so now we're back in Thingiverse. Let's go ahead and let's random generate some other things. Oh, sweet. Whoa. This has been powder printed. It's kind of unusual. I'd say we go ahead and try this one. This is a really interesting part. But this one, obviously, because it's a ball, there's no point in adjusting the orientation. However, we do have this kind of circular opening on the bottom. If I were to rotate this 180 degrees, 28 unsupported minima. That is funny. Let's auto-generate. Let's see what PreForm does with this. So you can see it's putting a touch point at each of these little prongs here. And you can see how there's some touch points on the bottom end of this, which are helping to support as it bridges. And so that might not be a bad idea to put some of those on this end. This is why it's always good to check. PreForm does a pretty good job, but it is all automated. So you definitely need a little bit of some human interaction. But yeah, some of these bridges in here. One of the reasons why I oriented this hole upwards, so it's not producing any cupping concern. So it's small enough to where it's not going to be any issue. But one of the reasons why I did this is because if that hole is oriented facing the build platform, it's going to retain some resin. It's going to capture some resin in there. So just by orienting it downwards towards the resin tank, again, because remember, we're printing upside down, by doing that, it just helps that resin just drain out. But you can see how with some of these prongs here, because that angle there is greater than 10 degrees, there's no issue. Although for some of these out here, I would probably consider it. If you want to add supports, you just have to go into Edit All, and you can go down in here, and you can just put little support touch points here. Click Apply, and you can see our part has been re-supported. Now, you definitely are going to have to be very gentle as you remove those support pips. You don't want to break these tips off the part itself. But I would say this part at this point would print successfully. Open RC F1 tire rack. We'll do this one because this is an interesting study in like how to print flat parts. So I'm just going to select this part here. We'll just download this one. Alright, so a part like this, flat parts can be interesting because with FDM you'd be inclined to just place this side flat down on the build platform, but you can't really do that in resin for the reasons I mentioned earlier. So what we're going to want to do is probably want to go through the route of the whole 30-degree thing. So you technically actually could print this standing straight up because you can see the cross-section is really thin moving up, and we don't really have any serious features per se in here. You do have some cradling that goes on, I guess, with the tires that fit in there and in here. So you potentially could get away with it. But what I would, you're going to have some supports printed up in here and stuff. So it'd probably be better just to orient it. What I might do 60 degrees. Alright, it's Joe from the future here. I just wanted to mention something as Joe from the past is fiddling with the orientation. The reason why I'm kind of tweaking and playing around with this is because I'm trying to find the right orientation that's going to minimize supports, minimize bridging, and therefore maximize our flatness.
Okay, you got it? All right, we're going to move ahead. Sorry to slow you down.
Yeah, I might do it like this. That way you don't have too many unsupported things. And it's starting up from the bottom and moving up along like that. And then this face is pretty steep here. So what I would do now is, let's do auto generate here. Yes, now you can see that generating. You can see we have really good supports down in here. Building up. Yeah, supports that region very well. Goes up along the edge. Cants that surface. That's interesting how it doesn't even support this wing. Technically it says you don't have to support it. I might, just in case, just because I'm paranoid, I might actually just generate some supports, just because this is kind of a thin walled surface in there. Get that one off, and that one off. Get that shot. I may actually go in and print this part and see how this looks, kind of test how flat it is, at least on this face. Kind of go from there. Oh shoot. And it was a value. One thing to note is that, and this is true with 3D printing in general, holes are going to print better if they are oriented like this. So a hole that's printed in the XY plane is going to print more accurately. Now, obviously, with the nature of resin printing, we're going to have to do some kind of clever angling here. But for a part like this, you could go up 30 degrees like so. And one thing you notice, see this kind of yellow region, this is a cupping error. So if I kind of scroll up through this part, what you'll notice is that right in here we start to form a suction cup, right? Because this is flat on the resin tank. And so it's going to form a suction, and that could pull the part off the build platform. So fortunately, PreForm's really good about kind of warning us of these warnings here. So ways to mitigate that is just basically modify the orientation, or if there's no way to modify the orientation, you could add a little like vent hole into the side of this wall here in CAD. But for a part like this, we could take this and kind of do our usual thing. That might help. You still have a little bit of a cup there, but I don't think it's too small for PreForm to register it as an error. It's not going to produce a strong enough suction. It's much smaller now. Another thing to note is the taller a part gets in the Z, the more time it takes to print. So that's kind of another thing you have to consider. And lastly, you'll see this white line generated. This is the seam line produced by this dashed line right here in the middle. This represents the boundary between the two light processing units. So now we have two lasers building up this part. And of course it gives us that little notification, hey, you have a seam line here. And you can always rotate this about the Z and pivot it over here so that you don't have that seam line. But I'd be comfortable printing a part like this. You know, I don't see any like drastic changes in cross section where it goes from like really small to really big. So I'd say this part's ready to print. Yeah, we could download this. Kind of like it. Okay. So first thing I want to do, just want to rotate this 80. So for a part like this, we have kind of some critical features here. Bearing slots into here. We have a number of like critical surfaces here where parts mate. You can see we got tons and tons of holes here, and something obviously slots in this region as well. The first thing that comes to mind, take a part like this, and I would say maybe do this at like 45. And this is like a flat surface. So 45, let's see, I can kind of step my way up through this. Profile looks pretty good. And then we can consider to do this one. I would say either orientation could work. You could do it this way, or you could do it this way. Both of them are valid. They both capture. All the details. They will both print very accurately, I think. Very nice. Added like a spine of supports for this. That might be okay. I think these supports might be a little overkill. I don't really think it's necessary, but then again, it doesn't necessarily hurt to have them there either. Critical thing is right down here at the very start, just making sure that you can see the supports. When you cant something at 45, it has to support on the edge. It's one of the probably only downsides of it. But this, let's say, seems pretty well supported. If you're paranoid like me, you could always add maybe a few more touch points. But like I said, PreForm does a pretty good job getting you like 95% of the way there. So again, make sure that is supported on its edge. Definitely seems to be. Yeah, so see, that's, you could maybe add another touch point like right there. Maybe I'll do that. Just go in here and just add one like right in the middle there. Just click apply. Oh, and maybe while we're at it, I'll just go in here. Maybe I'll just add like a few touch points right in there. Just make sure that's going well and good. Yeah, and if you wanted, you might add some supports in here. But holes are just so easy to ream out, you know? So easy to modify in post. Seems really well supported in here. And these ones that you see on this face, they're mostly just stabilizers. You know, you'll notice they're just on the outer edge. There's none actually in the center. Pretty comfortable with having this part printed like this. I like how this looks. I feel good about this. Yeah, I feel good about this. I think one thing you'll notice from this is there's a, you know, it's not always like cut and dry. There's multiple different orientations that could work. It's not like FDM where you're very limited on your options. This one, there's a lot of different things you could do. But this is just maybe what I would do based on my own experience. Oh, and as promised, I went and printed that flat part that we looked at earlier. So here it is right off the build platform. You can see our supports match what we put in on PreForm, and including that arced bit there, sticks way out high up. And just flipping it over on this flat surface, you can see we maintained a flat plane. You can't see any light peeking out from behind those edges, and there's no like rock or anything on the part. So that was a good support placement strategy for flat parts, which flat parts, as I mentioned, can be pretty challenging to support and orient on a SLA printer. Well, that's all I got for you today. Thanks for joining the webinar, and we'll open the floor to any questions you guys have.